Hey, good afternoon everybody from Lake Havasu City, Arizona. Ben here at EFI University. It's about 20 to 4, so it's not quite time to go home yet. We've been kind of just working away this week, getting ready for, not next week when we have our ACP course going on, but the following week we have this year's first CED, or Competition Engine Development course going. And this one's going to be interesting. We have a pretty fun project this time. One of our customers, one of our students for the class, called ahead and said, I'd like to take advantage of the program where, I come and we do the engine, but I get to keep the engine. It's my engine. So I think he called us back in maybe December or November, something like that, and we started the plan. And this is an interesting project this time. It's a little bit different than what we normally do, because normally we work on these really high compression, high RPM, what I call limited drag race engines. By limited, I mean they're budget limited. Other than that, they're pretty unrestricted. We could do anything we want. And so, we've been turning that little 358 thing 9,600 RPM and, getting after it a little bit. That thing makes crazy good power. The last few classes have had a good time with it. But this project behind me is quite a bit different, because instead of being totally unrestricted and unlimited, it's very restricted and very limited. This is a project that's a 6-liter stockish kind of LS engine class for a road racing project. So right off the top, we have a huge difference between what we would do in a drag racing engine and a road racing engine. All the configurations will be totally different. On top of that, they've limited our bore size, our stroke, what kind of crankshaft we can have, how much lift we can have on the camshaft, what kind of RPMs we can do. So a very, very controlled package. So now the challenge is, well, let's pull out all the stops and let's use all the tricks that we normally use in our basically unrestricted engines and try to see what we could get out of a very restricted engine within the rules. So this will be a 364-inch, basically a 6-liter. We couldn't use the tiny little rings that we're used to using. We can't use the shrunk bearings and the Honda journal size and all that. So we had to take advantage of all the other things that we can do, and we're going to be teaching our students here about how we go about doing that and how we analyze it. We got Billy Godbold at Competition Cams to design some lobes that are brand new, specific for this project in this application. The compression ratio, the weight of the car, manual transmission, road racing type deal, not a drag race deal. So literally, today's Wednesday. I think the cam was going to ship today. Billy designed those lobes for me on Monday morning. So last week, this camshaft literally did not exist, and this will be the very first one that anybody gets to run and see how it goes. So we've got a great combination that we feel like is going together. But we're kind of known for telling you guys the secrets, the really hard-hitting kind of hardcore tech stuff. And so I was looking for something that's just a little small thing that might be interesting for you guys that you could do yourself that will make a big improvement on your engines. And as we were looking around for some of the things we're doing, I found something that probably not a lot of people know about, and I thought I would just share it with you. So one of the challenges that LS engines have in general is the rear main seal and the front main seal. They're just not that good. They tend to leak a lot. They're very sensitive to the cover location because it has to be, centered on the circle on the back of the crankshaft. And frankly, they're not that strong. And so this being a road race application, one of the things we are able to do is to use a dry sump oiling system. And so while this one will eventually have a dry sump pan made by Aviad and a 5-stage pump that's remote mounted and hoses go to and all that, we thought that it was a little too complicated to get it all to fit on our dyno, and then a lot of wasted money between making all those fittings and hose links, and then it won't fit in his car. So we volunteered to let him borrow one of our 5-stage daily dry sumps. So if you want to check that out, this is actually the pan that came off our 358 from the last class. It's a 5-stage daily dry sump pump integrated to the oil pan. So if you look at the bottom there, the way this thing works is instead of having AN fittings and lines and hoses that go to a pump somewhere, this is actually bolted straight onto the pan. And then each of these stages, there's 4 suction stages, comes straight out of the pan, and it's machined into the oil pan there. And then of course over here we have our pressure stage, and the belt is turning the pump there. So pretty cool package overall. So we're going to be using this on the dyno. But one of the challenges to doing that is one of the advantages we get by going to dry sump is trying to pull some vacuum in the crankcase. If you think about it, if we said it was a 6-liter engine or 364 cubic inches, those pistons are displacing that volume of air on top of them in the valves, out the valves, but it's also trying to do that into the crankcase. So you've probably heard people talk about bay-to-bay breathing and balancing the airflow in the crankcase and all that. So one of the ways that we can dramatically alleviate that is by going to a dry sump system. Now, as the oil pump is pulling and trying to suck all the oil out of the pan, it's also sucking all of the available air that it can out of the crankcase. In order for us to actually have a vacuum, though, we can't have any leaks. So we have to cap off all the breather holes in the valve covers. We have to make sure that the valley cover plate is sealed really well. And one of the biggest places that you have a huge leak in the engine are the seals, specifically the rear main seal. The rear main seal on the Chevy LS engine is a nice design, but it's not a very good, strong design for motorsports applications. So I don't know how easily you'll be able to see this, but I got a couple of them over here. Here's what the factory seal looks like. It's just rubber. It's pressed in. It's actually fairly, I'm going to flip it over here. It's fairly hard plastic. This is a used one that's been taken out, so it's beat up a little bit, but I don't know if you can see this or not, but when you pull it, it doesn't really do anything. It just kind of gets deformed and bent, and then that outer lip is really, really soft rubber. So these tend to leak air in the back of the crankshaft, and you can actually hear it if we just take the oil pump belt off and put a drill and spin that oil pump motor. You can spin that thing, and all of a sudden the oil pump kind of goes, and it gets hard, and you stop, and you can, like, you know, uncap the oil filler tube, and it goes, and it sucks a bunch of air in. But if you don't do that, you sit and wait, you'll hear the engine hissing, sucking air in and trying to equalize that pressure, and almost always the major source of leak is that rear main seal. So over time, these tend to wear out. They're just not very strong. They don't hold a lot of vacuum, and the worst part about them is, man, they create a lot of drag and friction on the engine. If you don't believe me, what I want you to do is start assembling your engine, and at some point, take the rear cover and put the seal in it and stick it on the engine and bolt that cover on, get it all lined up the way it's supposed to be, and you will be blown away by how much harder it is to turn the crankshaft around when you do that. Right now, without all the pistons and rings and all that stuff in there, it seems pretty easy, but obviously the more stuff you put in, the harder it gets. But you will notice a huge difference when you put that rear main seal in. So, obviously, in a game like this, where we are trying to do three things. We're trying to improve the volumetric efficiency of the engine. That means we're going to try and do everything we can to get more airflow in the engine. That means our intake manifold design, the porting on our cylinder head, and the camshaft design and the header design all have to work together to move the most amount of air possible. So those are, we have ported heads, we have a Wilson fast, XFI style intake manifold, all within the rules that are legal, headers, so on and so forth. We've modified the compression ratio of the engine because a lot of people don't know this, but compression ratio does affect volumetric efficiency because of the leftover crevice volume on top and your expansion ratio and all that. But once we get the air in and we combust it, we need to capture that heat that we create and turn it into power. So we work on things like thermal efficiency with compression ratio, coatings, ignition and tuning and that kind of stuff like that, water jacket treatment, where the water is, how much there is, how fast it moves. Those are all things we work on for thermal efficiency. And then lastly, we have mechanical efficiency. That's the friction and drag. So normally on our drag race stuff, we use little tiny bearings and lightweight oil and tiny little rings and on and on and on. But those are all things we can't do in this situation. I can't use a super light 0.2 weight oil because it's a road race car that has to run for a long time and we'll end up having much higher oil temps. So we end up with a thicker oil viscosity. So we approached the driven guys and said, hey, what at the viscosity level that we need, what are some friction modifiers and additives that you can do that give us an advantage? And so we've done that. But when it comes to the rear main seal, I recently was introduced to a guy in North Carolina named Jeff Gunther. Now he has a company called Fast Fish Auto Parts. So go to fastfishautoparts.com. And he imports a very special seal that it took me forever to try to find these. In fact, it was Robin Lawrence at Holly, of all people, thank you, Robin, who introduced me to Jeff. He imports a seal from the UK that's specifically made for the LS engine. It has a PTFE impregnated liner. It has a double lip. It has a caged spring-style sort of clamping mechanism to help it seal better. And it's made for pulling vacuum. So this thing will seal at up to 18 inches of pan vacuum on a dry sump or an external vacuum pump system. So a huge difference if you look at these two seals together there. Huge difference in just the construction. When I turn the factory seal over, it's just a folded piece of rubber. You turn the Jeff's seal here over. It's molded. It's got a spring-loaded kind of, clamping mechanism. The seal, but not only is it really good for that high vacuum, so it won't leak nearly as much, which means we get better ring seal, we make more horsepower, we lose less horsepower, I should say. But it's actually impregnated here or coated with PTFE, basically like a Teflon style coating, which dramatically reduces the amount of drag when you put this thing on that cover and stick it on the back of the engine. You go to turn your crankshaft, man, you could tell immediately. Now they claim, the manufacturer, that it reduces the friction by about 50%. Now that's a huge claim, and I was a little bit skeptical, but I thought, well, shoot, anything's better than the factory seal. So I tried to set up a test and validate whether or not that was real. Now I realize this isn't an extremely accurate test, but it definitely makes a difference that you can do. And so what we did is we just stuck the crankshaft in, it's all torqued up, one connecting rod, one piston. And I took my torque wrench with the factory seal. I took my torque wrench, and I have to use this little bitty one that's 1/4 inch drive just to get low enough, and very gently test the breakaway torque. You guys have seen me do this before with the complete engine and rings and everything in just to see what it is. But when you have very little stuff in the engine, it's difficult to register and measure. But with the factory seal, I would typically get about 2.45 to 2.5 foot-pounds of breakaway torque to get that thing to move, and I could constantly keep pressure all the way around it. So I did that enough times to go, okay, I feel good that that's an accurate, I can repeat that measurement, 90% of the time. And of course, it's subject to how hard you slam on the wrench. You can make a big number if you want. Then we took it apart. I didn't really do anything except for swap the factory seal out for the Fast Fish Auto Parts seal. And we stuck that thing on. And before I even put the torque wrench on, I was like, wow, I can't believe the reduction in drag this thing actually has. Then I put my torque wrench back on there. And for a while, I had trouble even getting the darn thing to read because it literally just falls out of my hand. So that breakaway torque you can see was 2 pounds. That's actually a fairly high amount. I normally get like that under 2 pounds, about 1.5 to 1.75 compared to 2.5 pounds for that factory seal, And the big thing is I could just literally let go of it and the wrench just falls. A huge difference in drag. And so when you're looking for every last advantage you can get, and you have to pay attention to every part of the engine, something like that rear main seal can make a giant difference. So I expect the performance of that seal to really benefit us because we have a dry sump, so we'll be able to hold more pan vacuum without distorting the factory seal, which improves our ring seal and also makes more power because it helps us evacuate that system and control windage and oil and all that sort of stuff. Aside from the fact that that's specifically designed for vacuum, it has half the drag of the factory seal. So I don't know how much power that really adds up to, but obviously the faster the engine speed gets, the more that drag becomes important, and it's a huge advantage. You can hold the two seals in your hand, and you can immediately tell the difference in quality from a, Kragen, Parts Plus, AutoZone, O'Reilly's type, just give me a replacement seal, to that, GST style seal that's, so get on the website there at fastfishautoparts.com. Send him an email or call him. His name's Jeff Gunther. Really, really nice guy. Happy to work with you. I'm not a reseller. They are kind of expensive if you're used to paying 12 or 15 or 18 or 20 bucks for a factory seal. You might look at these and go, wow, those are expensive. But if you consider the factory seal was never designed for a performance application, was never designed to hold vacuum, was never designed to reduce drag, it's really not even a fair comparison. So you might pay more once, but it lasts 2 or 3 or 4 times longer than those OEM seals, which always end up leaking, and they definitely leak air and make it hard to seal pan vacuum. But give Jeff a call, send him an email, let him know that you're interested. If you're one of the LSS guys out there building a lot of these engines and you don't know about those seals, well, you're welcome. But you definitely don't want to build more engines without that seal. So I don't sell them. I don't get a kickback for selling them. I'm not in the product endorsement business. We are just in the business of doing the job as good as we can and sharing the information with you guys out there to make you better. So that's what we're going to try and do. As far as the rest of the secrets in this engine, if you want to know some of the things we do, well, you got to come take the class. We would love to see you come visit us. This one is just about full, I think. There may be one seat left for the one coming up in a couple of weeks, but in a couple of months, we do this class every quarter. We'll be back on it. We'll probably, I assume, be back on the 358 and doing the next change to that. But can't say enough thanks to all the people that support us in doing this. Robin at Holly, Billy at Comp Cams, Jeff at Fast Fish, and just tons and tons more people I can't remember. Thank all of you. And for all of you guys watching, I hope you found this valuable and informative and it helps you, get your project where you want it to be and make it better. If you have any questions, shoot us an email, Facebook, like, share, do all that stuff. But while you're figuring out how to do that, I got to get back to work, so I'll see you later.